#hashtag walkthrough JPGChat day 24. #hashtag objective. The objective of this engagement was to assess the security of the JPGChat application, gain an initial foothold on the target system, escalate privileges to root, and document the entire attack path. #hashtag phase 1 reconnaissance. The target machine was deployed from TryHackMe and connected through the VPN. A full TCP port scan was performed using MAP to identify exposed services. The scan revealed two interesting services. /TCP/22 OpenSSH /TCP/3000 JPChat service. The banner presented by the service indicated that it was a custom chat application and suggested that the application's source code could be found on the developer's GitHub repository. /evidence /01 room started.png /02 map full scan.png /03 chat banner.png #hashtag phase 2 application enumeration. Connecting to TCP port 3000 using Netcat displayed the application's available commands. Two primary functions were available: /message /report. The service appeared to accept user-supplied input without obvious validation. The source code was located on GitHub and reviewed to better understand the application's functionality. /evidence /04 protocol enumeration.png /05 github source.png #hashtag phase 3 source code review. The GitHub repository contained the application's Python source code. Reviewing the report /form function revealed that user input was passed directly into os.system. Because the input was inserted into a shell command without sanitization, it was vulnerable to operating system command injection. This provided a clear path to remote code execution. /evidence /06 source code analysis.png #hashtag phase 4 initial foothold. The vulnerability was first verified by executing the ID command through the report functionality. The command executed successfully and returned the identity of the running user, Wes, confirming remote command execution. A reverse shell payload was then supplied through the same vulnerable parameter. A Netcat listener on the attack machine received an incoming shell connection. /evidence /07 report submission.png /08 reverse shell.png #hashtag phase 5 shell stabilization. The initial shell was upgraded into a stable interactive terminal. Environment variables such as term and shell were configured to improve usability. A stable shell simplified further enumeration and privilege escalation activities. /evidence /09 shell stabilization.png #hashtag phase 6 user enumeration. The file system was explored beginning with /home. The home directory belonging to the Wes user contained user.txt. The user flag was successfully retrieved. Additional enumeration identified pseudo privileges assigned to the compromised account. /evidence /10 user flag.png #hashtag phase 7 privilege escalation. Running sudo-l revealed that the user could execute without a password while preserving the PYTHONPATH environment variable. Reviewing the script showed it imported the module. Because Python searches directories listed in PythonPath before system locations, a malicious compare.py module was created containing code that spawned a root shell. Executing the privileged script while pointing PythonPath at the malicious module caused Python to load the attacker's code instead of the legitimate module. The result was a root shell. /evidence /11 test module source.png /12 compare module.png /13 /root /shell.png /# phase 8 completion. After confirming root privileges, the root flag was successfully captured. The room objectives were fully completed. // evidence / /14 /room /complete.png / attack chain summary 1 / enumerated exposed services 2 / connected to JPGChat 3 / located GitHub source code 4 / identified OS command injection 5 / achieved remote command execution 6 / obtained a reverse shell as WES 7 / stabilized the shell 8 / enumerated pseudo privileges 9 / identified preserved Python path 10 / performed Python module hijacking 11 / escalated privileges to root 12 / captured both flags / outcome. The assessment demonstrated how insecure shell command execution and unsafe Python module loading can combine to allow complete system compromise. No brute force attacks, kernel exploits, or automated exploitation frameworks were required. The compromise relied entirely on manual analysis, source code review, and exploitation of insecure application design.